So, good afternoon, everybody, and thank you for attending this session on LISTtalk, the first edition, on the topic of energy transition, challenges and opportunities. For today, we have an interesting panel to discuss different issues on the energy transition. So, we invite you to see a little bit of what we have prepared for you. And for this, I will start by a short word on this series of conferences. So LISTtalks, this is the first edition to be launched. Basically, this conference series is expected to bring together stakeholders, researchers, industry, and authorities to answer state-of-the-art research and innovation questions on the environment, climate change, sustainability, and strategies and design, some of the topics that have been in the order of the day and topics of many discussions in the scientific research community specifically, but also in the society in general. So with this, this brings me to the first theme we chose to present, because this is actually a really important theme that has been addressed in Europe, and which is energy transition. So as you should know, the European Union is pushing for an energy transition with a very clear goal of net zero carbon emissions in Europe to be reached by the year of 2050. So this has a lot of impacts in the way we work as a society, and specifically the energy system is required to comply with some of these changes. Decarbonisation probably is the word that you will relate to this. So we are in need of a decarbonisation of the energy system. And for those of you who are following the subject, this means a very structural change to the way how we operate. So a shift in the global energy sector, moving away from fossil-based systems to energy generation that comes from renewable energy sources. And with this, of course, come many different significant challenges on different aspects: resource use, system structure, scales, markets, economics, but also end user behavior and policy. Although these are some of the challenges, whenever there's a challenge, there's an opportunity. So we have now the opportunity to develop specific solutions, especially solutions based on digitalization, information communication technology, services, new policies, new market frameworks to respond to all of this. So with this in mind, we have chosen these three important vectors that make up the energy transition. They are not the only ones, of course, but starting by the first one on energy policy, there is the need for effective policies that can support this energy transition, that can promote integration of renewable energy, that can help improve energy efficiency. And we'll have a talk that will be addressing the topic on energy policies in this context. The second vector is around energy markets. So there's a pressing need to push for innovative energy markets that ensure access to all the relevant players and that enable competition in this increasingly dynamic environment. So we'll have another talk focusing around these issues, also with a technical aspect. And finally, at the end, or at the center somehow, because we are all at the center of this, there is the end user. So there's a need for empowerment of the consumer in this energy transition, realizing this user-centric vision of the future energy systems that can be increasingly supported by digitalization and ICT. So that's why we chose the panel that you are going to hear now. So this is the program. We will then go for the first presentation, who will be more focused on the energy policy by Laura Kainiemi. Then we will have 5 minutes of Q&A to to address some specific questions on the presentation. Then we'll go for the second presentation by Yannick Fulfil, more on the market and technological aspects. Another 5 minutes of Q&A, and then the final presentation will be made by Philippe Soares on the end user behavior. And then this should be followed by 5 minutes Q&A also, and we will have time for a general Q&A session, let's say, or a discussion with the members of the audience. One thing that I wanted to let you know is that you should ask the questions in the chat that you have there, the possibility to use the chat, and ask the questions during the presentation. So as soon as you are seeing it, you want to make a question, write it, and in the end, I will be reading your questions, and the panelists will be able to respond accordingly. So I really urge you to do this as soon as possible to make this also more efficient, and we don't have to wait. So just to kickstart this, and without taking much longer, I would like to propose to make this first poll. We have prepared a poll on this that you should vote for. So the poll is to answer this question: what will be the main challenge for the energy transition? And you have several choices. So the first, renewable energy sources integration; the second, energy market development; the third, supportive energy policies; fourth, user engagement and awareness; or other. So I invite you to choose whatever is your preferred choice now, and we will check the results at the end. Okay. So we'll take a few minutes so that you can vote, but in the meantime, I will start presenting the first speaker of today. So the first speaker is Laura Kainiemi. So Laura is a postdoctoral researcher at the School of Energy Systems in Lund University. She finished her doctoral studies at the Department of Energy Conversion in Aalto University in 2020, while she was a visiting fellow at the University of Luxembourg's Institute of Political Science. Laura's research has been focused on the interface between technologies and the society that surrounds them, and she is currently working on the environmental and social sustainability of the circular economy. She is interested in the influence of policy, institutions, and actors on technological development, sustainable innovations, and the energy transition. Laura has a multidisciplinary background that combines energy engineering, environmental economics, as well as political and social sciences. So with that, I pass the word to Laura for this first presentation, and you should have control of the screen now. And please, Laura, go ahead.
Okay. Thank you, Andre, and good afternoon, everyone. As Andre mentioned, my talk today will focus on the actors and how actors can influence energy policy as well as the energy transition. And the content of my talk is mainly based on my doctoral dissertation. So if you want more information, you can find it freely online. And I am trying to change the slide, but it doesn't seem to be working. Ah, here we go. Okay, so the motivation behind my research is that as more and more governments are acknowledging the urgency to address climate change, and they're implementing increasingly ambitious emission reduction goals. For instance, the EU aims for carbon neutrality for 2050. Finland aims for carbon neutrality in 2030, and the Paris Agreement amended the previous aim of limiting global warming under 2 degrees Celsius to 1.5. So we have these more and more ambitious emission reduction aims. But when we look at the policy side, so if we look at the graph and the blue line of the graph that is indicated by the policy measures that are currently in place, we can see that there's a significant gap between the blue line and the orange line at the bottom of the graph that indicates the level of policy that would be necessary to reach the aims of the Paris Agreement. So my interest basically started with, why is there this policy gap? And what do we need to do in order to bridge this gap? So today I will mainly focus on providing you with the context. I will introduce a case study of actors and energy transition in Finland, and then I will conclude by explaining how the results from Finland could be applied and what do they mean on a more international arena. And there seems to be quite a delay in changing of the slides. Okay, there we go. So I asked the question, what is the cause for this gap in policy? And one of the major reasons for this is the existence of technological trajectories. And technological trajectories form because new innovations tend to build on existing technologies. So they tend to be modifications and upgrades rather than radical inventions. And as technologies develop according to these pathways, institutions form around them. And these institutions are necessary to facilitate the use of these technologies. And they can be formal laws or regulation, or they can also be informal, such as the values of the society that surrounds them, industrial practices, or expectations regarding technological potential of different innovations. And in order for new innovations to really become a significant part of the energy system, they need to be compatible with these existing institutions. And if they're not compatible, these institutions can slow down the development as well as the adoption of these technologies. Institutions change over time, but this takes place very slowly. So we're thinking about the range of several decades here. And when we're talking about climate change, those are decades that we do not have. So what do we need to really speed this institutional change in order to meet these emission reduction goals? Typically, we look into policy, and in particular, different destabilization policies. And the purpose of these destabilization policies is to quite literally destabilize existing technologies, institutions, or actors in the energy system in order to make space for these new innovations to emerge. And they can be limitations to the use of existing technologies or just removal of financial support for them. Recently, research has started to pay more attention in the role of actors, both in a process of energy policy and particular the differences in power relationships between different actors and how different actors have different abilities to influence energy policy and through that the energy transition. But actors can also influence institutional change outside the official policy processes. So when we think about actors in the energy system, we have a wide range of different actors, ranging from academia and citizen activists to environmental, non-governmental organizations, as well as industry. And in this case, industry means the large energy utilities, energy intensive industry, as well as renewable energy producers. So typically in research, we see these actors divided into two main groups. There's the disrupting actors. Typically, these can be citizen activists, NGOs, who are trying to displace elements of the system and to start or speed up an institutional change. And then on the other hand, we have the incumbents, the large, powerful utilities who are trying to resist these efforts for change. But my starting point was kind of that the reality in practice is far more complex than this division of actors into two confrontational groups. And more incumbents are also participating in developing new technologies and adopting them. So in order to look at this complexity, I wanted to see what kind of strategic institutional work actors are engaging in. So what do they do in order to maintain existing institutions or to defend these institutions from actors who are trying to disrupt or displace them? And what kind of activities are they undertaking in order to create new institutions or to modify the old ones? And in addition to this, I also wanted to include what I called the human factor, because humans are prone to mistakes and errors, and they make decisions based on their past experience. And this is not always the best predictor for future development, especially in a situation where we're undergoing a system transition. So to do that, I use the concept of mental models, and this is mostly used in psychology and organizational studies. And basically, when we're looking at mental models, we're looking at how the actors frame the problems that are being solved. What do they see as feasible solutions to these problems, and what solutions are left out of consideration? So basically, these mental models are kind of simplified images of complex realities, such as the energy sector, and they're necessary so that actors can make decisions, because they cannot consider every detail in their decision making, but they have to leave out some aspects and only include the aspects that they consider important. So as they're leaving out certain aspects, there is a risk that these mental models can become distorted, or they can be oversimplifications of reality. And these kind of mental models can be very harmful when they're reflected back into the institutional level and energy policy. And they can really lead to institutions that slow down the development of sustainable innovations. And next, I will briefly introduce the case study of looking at actors in the energy transition in Finland. And when you're thinking about Finland, you're probably thinking about a technologically advanced Nordic country with a high share of renewable energy. And while this is true, there's also certain features that make Finland a very kind of fruitful case study to look at institutional inertia and technological trajectories. And first of all, Finland is relatively energy intensive. So if you look at the graph, you can see Finland is well above the EU average in energy intensity. And this is mainly caused by energy intensive industry, such as steel making. And on the other hand, Finland has a very centralized energy sector. So there is a handful of large utilities that control more than 90% of the energy market. And this comes with a very stable set of institutions in the energy system. And there is a long tradition of placing high importance into being able to provide affordable energy for this energy-intensive industry so that they can maintain their competitiveness in the international market. And this is reflected in the energy production side in this valuing of economies of scale, which upholds the decentralized structure and the focus in large units. And hand in hand with this goes this emphasis of market-led development. And this particularly tends to come up in discussions about increasing policy support for renewable energy, which is often met with resistance because then actors start voicing the need to allow renewables also to develop in a market-led fashion. And because of this centralized structure of the energy sector, there is this core network of key actors that have been working together over several decades. And in many cases, these key people in these organizations also have a personal relationship with each other. So they know each other over long periods of time. And this can be problematic for new actors, ENGOs, citizen activists, and different environmental movements, because it can be hard for them to be included in discussions about energy policy, because a lot of the discussions take place in a more informal setting and kind of behind the scenes outside the official policy processes. But on the other hand, typically Finns are very enthusiastic for new innovations and to try and to start using new technologies. And as a result, there is a lot of support available for R&D activities and for clean tech development. Also, many new actors have emerged in recent years, and particularly there's been a new type of actor, this kind of loosely knit citizen movements or movements formed by small renewable producers who are becoming more and more vocal in discussing energy policy and the need to speed up the energy transition. And just to give you a brief idea on what technologies were looked at, I wanted to focus on mainstream technologies because then they're more likely to have these problems of being incompatible with the existing institutions. So I was looking at small-scale decentralized renewable technologies, as well as one carbon capture, utilization and storage application, where CO2 was converted into solid minerals that could be used in paper making or road construction to replace virgin materials. And first, I looked at institutional side and what institutional obstacles were there for each of these technologies, and what was the level of institutional support for each of them, and what was the level of decentralization policy in the level of the entire energy system. And then to look at what mental models actors held and what kind of institutional work they were engaged in, I collected 3 different sets of research interviews. And what we found from this is that when we look at the institutions and the mental models at the level of these individual technologies and the institutions that are directly influencing them, we get a very positive image. So there's lots of R&D activity and a lot of support for R&D activities, and market development is increasing rapidly. But when we take a step back from the level of these individual innovations and we look at what is going on at the level of the entire energy sector, we get a somewhat different view of what is going on. And there's 2 major issues here. And the first one is that there is a relative lack of destabilization policy. And in some cases, even increasing support for existing technologies. And the other thing is that there are some harmful mental models that have become solidified as informal institutions. So they have been widely accepted by most actors in the energy system. And one example of this is that almost all of the technologies that were observed were considered marginal technologies. So to have a marginal role, at least in a domestic market, and to be mainly a marketable clean tech product for export. So there was very low expectations in terms of technological potential. And this has resulted in a low level of policy support for these technologies. And this is problematic when it kind of becomes a self-fulfilling prophecy. So this low level of policy support resulting from the low expectations results into these technologies remaining in a marginal role due to the lack of support for their development. We also found that there was some discrepancies between energy policy at the EU and the national levels. For instance, as recently as 2017, a new law was passed that mandated compensating energy-intensive industries for the costs of the EU emission trading program. And a law like this directly undermines the effectiveness of the emission trading program because it removes the incentive of these companies to lower their CO2 emissions. So when we look at what actors are doing in the energy system, in interviews we found that all actors in the Finnish energy system were extremely committed to achieving a carbon neutral energy system. And while this seems great on the surface, there were large differences on what they defined to be carbon neutrality. So their definitions range from carbon neutral with a share of nuclear energy or bioenergy to 100% renewable, to truly emissions free, which would not even allow for a share of bioenergy. So they were seemingly talking about the same thing, but they were meaning different things. So this can be very confusing in terms of cooperating in terms of energy policy. And when you think about what types of institutional work these actors were engaged in, all actors were participating in creating new institutions, even the incumbents. And other types of institutional work were downplayed or they were quite rare. And what was maybe most surprising here was that disrupting work was avoided by actors that you would expect to be disrupting the system, citizen activists, NGOs. And one NGO said that this was a conscious choice for them to focus on the positive aspects of renewables and to avoid criticizing other elements of the system. And the aim was really to ensure a good discussion with other actors so they could cooperate with them and to achieve at least some changes in the system in advancing renewables and the energy transition. And there were two instances where actors were trying to disrupt the existing system by criticizing the current energy policy. And both these actors were met with very strong defensive reactions from other actors. And they tried to discredit these actors, really. And this was also visible in interviews because the other actors described these disrupting actors as unrealistic. You know, they have the wrong facts, they need to check their facts, and they just simply didn't know how things were done in in an operational level. So they were misled, and they didn't really know what they were talking about. So we can see that these actors are clearly impacted, if not even constrained, by existing institutions. And this is the case even for actors that you would expect to be criticizing the existing system. And it's clear that actors who are part of that key actor network discussed earlier have more power to influence not only the direction of the energy transition, but also the activities that the other actors are engaging in. And finally, what can we kind of learn from this Finnish case study in the context of other countries and in a broader sense? I think one of the main messages is that when we're looking at sustainable innovations, we really need to, in addition to looking at that individual technology, we really need to take a step back and zoom out and look at the big picture. So at the level of the entire energy sector, not only that surrounding that particular technology. So we need to look at what institutions are there, where is institutional change heading to, and what are the other actors doing in the energy system. So it's clear that actors can influence energy policy and institutional change. And it's likely that this effect varies from one country to another, depending on their institutional setting. So in countries like Finland, where that has a very stable institutional setting, it's likely to be more constrained. Whereas in countries where the institutions are less well defined, actors are likely to have more freedom in criticizing elements of the existing system. So this institutional inertia and a presence of powerful actors can definitely slow down not only the development and adoption of sustainable innovations, but also the energy transition, or influence the direction where the energy transition is heading. And because of this, institutional change should not be really left up to the actors, and therefore we need decisive destabilization policies to make space for sustainable innovations. So in order to really be able to bridge that policy gap and meet these aims of carbon neutrality by 2050 or 2030 and limiting global warming under 1.5 degrees, this seems to be imperative. But this should also be done in a way that includes all the actors in creating these new institutions and this new energy system. Also because this is likely to diminish the amount of maintaining work and defending of the existing system that these actors will engage in. So in addition to trying to achieve environmental sustainability, we also need to be mindful of this social sustainability aspects. And this concludes my part today. And there is some time for questions now and as well as later, and you can always email me at the address displayed in the screen. Thank you.
Thank you very much, Laura, for this presentation. We have one question for from the audience, but actually, okay, this is more general, not specifically for your presentation. So maybe I will leave it to the end. The first question that is in the chat. There's one specific question to you. So what are the existing versus the new technologies Are, for instance, wind turbines operated for more than 10 years considered as existing?
When I was talking about existing technologies, I was mostly referring to the mainstream technologies that are being used. So in the case of Finland, these would be the traditional fossil fuel sources, nuclear energy and bioenergy.
Okay, thank you very much, Laura. So for the sake of time, I think we move along. This more general question that we have here in the chat, we'll try to address it in the end. Okay, it's from Stefan. We'll try to address it in the end if we have time. For now, I think we should proceed. So the second presentation of today is to be made by Yannick. So a brief word on Yannick.
Andre, I can't hear you. I don't know if I'm alone. People can read. Yes, me neither. Andre, what I propose, as people could read my curriculum, maybe we can switch and I go to the presentation and we can try to fix the mic. So happy to be in the webinar and thank you, Andre, for welcoming me in this talk. I'm not sure I can switch the slides either. Yes, it seems all right. Perfect. So my talk would be a bit at the crossroads between the policy aspect and the technology aspect. The idea is to discuss a bit how we collectively can achieve the energy transition that we all wish to decarbonize the system, to also go to the policy defined targets of development of renewables and of other technologies at least cost. And this is really a critical dimension, at least from my perspective, as we've seen, for example, 2 years ago, before the COVID crisis, that sometimes when you want really to give a direction that is shifting things and going to a different dimension, you need to give signals, for example, taxes on oil for cars. And this can really create some kind of social disruptions and social differences that as a society can hardly be accepted, in particular when it really increases the cost. So my talk will go a bit on this line, and I will focus through my speech on a specific technology which is transmitting electricity and generating electricity offshore, so in the sea, for example, with offshore wind turbines, as it is illustrated here. I'm sorry because I can't turn the slides. Maybe Andre, if you can help me. Yeah, all right. So the idea, as I was saying, and it's good for debates, but I kind of disagree with the presentation that we had before, at least on the observations. At least in Europe, the targets for the development of technologies is very much policy oriented. And we've had, over the last 5 years, discussions at the European Parliament with our deputies, but also at the European Council with our elected representatives, discussions on how much energy efficiency, how much renewable energy, how much carbon emission we want to have in 2030 for example, where we've defined targets. And those targets are even defined further at member state level. And as a matter of fact, when we are discussing, for example, technologies for electricity generation, the targets defined by the 27 member states together were even more ambitious than the one defined at European level. We reached 33% of the electricity generation, whereas the European target was 32% in 2030. And I think this is positive that the governments and our elected representatives can take such decisions and give those directions. And sometimes for even more specific technologies, they can give even or refine even further the directions. So for example, the European Commission last year in 2020 prepared and published an offshore renewable energy strategy where they defined targets. So those are indicative, they are not committing. The 2031s are committing targets. The one for 2050 are indicative, where they foresee the development of massive amounts of electricity generation offshore. 340 gigawatts of offshore wind energy and offshore ocean energy will be developed by 2050. So this is really a massive uptake of this technology, which comes at a cost. One will have to invest in offshore generation, but we will also have to invest in transmission network to take the power where it's generated and bring it to the mainland where it can be consumed. On the other hand, and also based on all those plans that are made at national level and that are massive disruption in only 10 to 30 years, it's massive. We've never done it before. We also have plans to develop further cross-border exchange capacities, and so the possibility to transmit power from one country to another. And here again, we have European exercises to see what is necessary, how we can make it best. And this exercise is called the 10-year Network Development Plan. It's made by ENSOE, a European Association of Transmission System Operators, and ENSOGI together with the gas. And they foresee almost a doubling of the cross-zonal exchange capacity by 2040, and in fact, increasing it by almost 100 gigawatts compared to what we have today. So I'll go to the next one, or if it doesn't go, maybe you can help me, Andre, thank you. One of the very nice and interesting technologies that is somehow coming from those targets is a possibility somehow to have all the grid that will be developed to connect offshore generation to the mainland, so we can take the power, for example, when there's wind, and bring it to the consumer. In fact, it might be that it will not serve when there's no wind. And one of the ideas is to make use of this infrastructure that comes at a cost and to use it when there's no wind. And as part of the offshore renewable energy strategy, the European Commission has somehow taken stock of practical experience and highlighted the possibility to make what they call offshore grids, offshore hybrid grids, by constructing what you can see here between two offshore wind farms, Kriegers Flak and Baltic 2, an additional network element, quite short in distance and in fact not so expensive, that will make it possible to use these pink links that are mainly aimed at transmitting the offshore wind that is generated, to use it when there's no wind, to exchange electricity between member states. And so this is what they call the hybrid offshore infrastructure, or multi-purpose interconnector. And this is somehow the first of its kind, I think, in the world that was put in operation last year, also in December. So I'll detail right now a bit what are the implications, in fact. So it's very good. We have this target. It's probably very efficient also in terms of costs. Once we have this infrastructure to take offshore generation, to add a little bit to make multi-use and take benefits when there's no wind. One of the key dimensions is in fact to invest in this infrastructure. And if we take the figures we have today in terms of investment, so this one is from 2019, it's prepared by the International Energy Association, the agency, sorry, almost 95% of the investment in the world in the electricity infrastructure is in fact regulated. It means that the one who put the money in the infrastructure is 95% certain of getting revenues back from it for its investment. And so it's relatively easy. But in Europe, for generation, the target model and the model that is very much promoted, and we've had, for example, even yesterday, a declaration from the French energy regulator that was really calling for this development. The target is the yellow section, where investment in generation assets is expected to be somehow fully exposed to energy prices. And so when you invest, you will rely on future revenues that depend on market prices. And this means that for the investors in offshore wind farms in particular, or in offshore ocean energy, you can't really be sure of how much you will get. And your future revenues might be a bit risky. And what I develop in the next 5 minutes is a bit how we can make this, only with market design arrangements, a bit less risky. So one of the key questions, and it is highlighted very clearly in the staff working document of the European Commission they published in December last year, is a question of bidding zone. A bidding zone, you can see here in this example, the bidding zone are the areas that are rounded with dotted points. It defines an area where the markets will define a price at which the generation will be sold. And the definition of bidding zones up to now is really a prerogative of the member states in Europe. Every country can decide to have one or multiple bidding zones. Even some countries like Luxembourg is in a common bidding zone with Germany. And it is very strategic for an investor that will be exposed to market price to know what is the price he will get for its asset. And any possibility to change bidding zones can be very detrimental to investment. Maybe to capture a bit better this idea, just take the example, you want to invest in a house in a green field, and you can build it in the bidding zone 1, in the offshore location, or in bidding zone 2. And depending on the bidding zone, your kids will be allocated to one school of the city 1 or the school of a city 2. If you know before you make the investment where in which city your kids will go to school, somehow it gives you confidence, and maybe it will ease your decision to go and invest or in bidding zone 1, or in the offshore location, or in bidding zone 2. Why it becomes a bit tricky is the European Commission, its proposal, proposed to create offshore bidding zones. And so that would be, if you build your house in the offshore location, you don't really know whether your kids will go to school in city 1 or in city 2. And they will go in the city where there is room in the schools. It has some positive aspects in terms of efficiency, maybe because it will fill the schools. But as a parent, and when you have your child, and when you would like to know in which schools they will go, and maybe you have a preference between city 1 and city 2, as an investor, maybe you won't invest in a house in this area where you don't know where your kids will go to school. And so it's a bit the same, in fact, with this dimension in terms of bidding zone. Creating an offshore bidding zone makes it very risky for offshore generators to invest, because they don't really know what will be the price that they will get for their assets. And so the alternative would be to have somehow bidding zones that encompass the mainland, but also part of the sea. And in that case, as an investor, when you invest in one country, you know you will get the price of this country. So this is somehow one example of a risk that the investor might take and that can have a huge impact on its future revenues. Where it can make the energy transition a bit costly is in fact because when you have a risk on your expected revenues, this is the blue part in the middle of the slide. In terms of cash flow, you have a range of uncertainties on your future revenues, and it might depend on the bidding zone where you are. Then, in fact, it disturbs the investment equation. And if you don't know how much you will earn in the future, somehow the bank will request a higher rate of return for them. And so it will increase the cost of your investment. So again, think you want to invest in a house, but you don't know what will be your salary over the next 20 years, then the bank will ask you a very high rate to loan you the money for the house. If you know exactly how much you will earn, you have 100% job security, then you can have a higher rate and you can invest somehow easier and at a lower cost in your asset. It's exactly the same for offshore generation in our case. And so the idea that we've developed and also that we've discussed a lot, when I say we discuss a lot, I refer to discussions I can have with colleagues, for example, at Eurelectric, the European Association of the Electricity Industry, where we've developed a paper. I have placed a reference in the last slide, and you can read the paper. What we've discussed is, in fact, all these implications. Is it better to have offshore bidding zones? Maybe you can get a small bonus in terms of short-term efficiency, but higher risks, and in the end, less investment or more expensive investment, or whether it could be more beneficial to have something stable. And so the concept we've developed is to, and that we are promoting, is the fact that when you are in an offshore bidding zone, the offshore generators, they are exposed to some risks which they cannot manage. For example, they are exposed to the risks that the network is not ready to connect new generation. New generation comes in, and then it would lower your price. As a generator, when you make your very first investment in offshore wind, you don't know whether the TSOs will make the job, develop the network, and whether the price will remain. And if you're in an offshore bidding zone, basically you are exposed to this price. And so what we've tried to develop as a concept is a concept where we try to allocate risk to investors that they can manage. And with this principle in mind, we believe it can really lower down and significantly the cost of the energy transition. I'll come to my last slides if it pops up. Yes, good. So we promote in the paper, and I'm happy to discuss it because it's a brand new topic. We see massive investment is needed, probably regardless of the design, massive investment will happen. The real challenge is to make it cheap, because in the end, it will have an impact on the bill that is paid by the end consumers or on the taxes that the citizens pay. For example, when subsidies need to be allocated to generation. And so the idea is to promote first the stability of bidding zone configuration. It's not good to change all the time. It creates risks and it increases the costs for capital, and so the cost for the investment. To address as much as possible potential congestions of the network when you connect assets or before you connect assets, so that when you connect, you know what will be the situation and what are the conditions to be connected. And also to allocate risks on network development or on network operation to the right parties, and in that case, to transmission system operator. And all those principles that we've developed and discussed in the paper, in fact, what's interesting is it applies exactly the same to onshore assets, be it wind, solar, nuclear, even gas generation. All of this, in fact, is also exposed to the same risks. All of the transmission network that we have on the mainland is also multi-purpose. It serves to make cross-border exchanges, but also to serve demand locally. And so all of this discussion can also work. And maybe just to close, I wanted to give a bit of an R&D perspective because I'm still quite involved also in R&D works with EDF R&D and supervising some PhD students or discussing with them, and also reviewing many papers. And I see, for example, it's very common to have in the European Horizon 2020 or the new framework, the perspective of policy aspects of policy recommendations for projects. Usually you have a work package on this. And most of the time when you have a project that focuses on a specific technologies, you really think of the market design as of how can I make it right for this new technology? And it's natural, and I think it's a good idea. The market must be made in a way that it accommodates all technologies. So it's right, but many times the consequences of changing the market is very poorly addressed. And in fact, when markets can change, it means that for assets that are already deployed, and they might be new ones, wind, solar, hydrogen, okay, fine. Once they are deployed, if you change the market rules, it means their remuneration is changing. And so it's really a risk for them when they develop to consider the risks that markets and policy changes after a while. And this risk is quite rarely taken into account. And the second dimension is, in general, well addressed. When you discuss market implications of new technologies, you would take it from a societal perspective, like economic welfare. And then you really need to take a focus on the full value chain and not, for example, in my particular example of offshore hybrid grids, from the TSO perspectives, whose costs or revenues are in fact regulated, but they are not, they are just transmitted from one stakeholder to another in the same value chain. So it's not really a cost in terms of efficiency. So I'm done with what I wanted to tell you. I hope it was clear enough, and happy to take a few questions.
Thank you very much, Yannick. I hope the problem I had with the mic is already solved.
We can hear you.
Excellent. So thank you very much for your presentation. I was looking at the questions, one from Stefan. So you mentioned this target of 340 gigawatts offshore energy in 2020. What will be the percentage of energy needed by that time? So this is...
I mean, the figures, they exist. I can give you an order of magnitude. I don't know the exact figure, but basically for offshore wind, it runs full power equivalent more or less 40 to 50% of the time. And so with 340 gigawatt of installed, what would be expected is to have it generate somehow around 20 to 30% of the energy consumption.
May I? This is Philippe.
But
I have that figure.
Go on. Okay, great. Go on.
Okay, I made very fast calculations because I saw Stefan question when you were presenting, and I think that it should be around 20% of the consumption. Okay, it was very fast. So they say that you will have 4,000 terawatt-hour of consumption in 2050, and I consider 2,500 equivalent hours, which is low, so it's a low figure. And even so, it gives 20% of the consumption covered by the offshore wind power.
Exactly, and you would have these figures, for example, in the long-term strategy. It's a document that is published by the European Commission, and you have this kind of figures that are detailed depending on the scenarios you take to see what share of the energy consumption it represents.
Okay, thank you very much. And Philippe,
and thank you, Philippe.
You already introduced yourself, so good. No, before you start your presentation, just a brief words on you. So you received your physics degree, electrical engineering postgrad and PhD in sustainable energy systems in the MIT Portugal program from the University of Porto. Philippe is a senior research and area manager at Inesctec, assistant professor at Lusófona University of Porto. He was project coordinator of the H2020 feedback project. You will see why this is relevant. And his research activity is directed towards the development of advanced functionalities for flexible resources management, participation in electricity markets, and the integration of energy vectors and grids. So, Philippe, I will pass you the control, and you should be able to change the slides. And
thank you very much, André, for the presentation and for the invitation to participate in this event. See if it works. Okay. So my talk will be about changing users' behavior to achieve the energy efficiency targets that the European Commission established for 2030. Okay, so you know that the target is 32.5% in 2030. This is a quite huge target and very difficult to measure. So it's always based on estimations. But the European Commission expects to achieve these values through building restoration, among other measures, but this should be the most important ones. Efficient equipment, you have here an icon of household appliances, but this is broader. It also covers industry and office buildings, and through behavioral change, which is the topic that I will talk about in the next slides. So by now you should be asking why you see here that feedback logo. It's feedback. It's a European project, and I thought about this presentation a little bit, and I had to decide between bringing a more theoretical approach or to explaining what really happened in the field in the project that we had about this. I chose the second option, so you will see what we developed and the problems that we have and the main conclusions that we reached. So about feedback, it's a European project in H2020, and the main goal was to develop, integrate, and test new technologies to promote energy efficiency and try to make the users change their daily behaviors, both at work and at home. Okay, the project. Okay, let's see if it changes. Not changing. Okay. Duration was from November to 2017 to April 2021, so it finished a couple of months ago. And Andrea, can you help me here? It's not working. Okay. So this is a very simple scheme to show you the, let's say, overall architecture of the project. We wanted the end user at the center of our research, and for that we developed a, let's say, front end of the project, which is that mobile app that you can see on the right side. Then we had some RESTful APIs to make or create interaction between the application, which was used by the users of the buildings, and all the work that we developed in the back office. So you can see here that we had a huge database, and the database was used to collect data from meters and sensors in the buildings, and meters were for measuring energy consumption, and energy, I mean electricity, gas, and even hot water. And also we had a storage of videos for awareness and engagement of the users that I will show you later. And this database was in a server, and the server had other functionalities because we developed several applications, algorithms that were running in this server connected to the database. Okay, about the mobile app and the critical aspect of this experience with the users. We developed a mobile app that we try to be attractive and easy to use. You have some functionalities here. It had multi-language. We had 3 demonstrators. You can see here the languages that we used in the application. There was some screens where you could log in or register yourself. Of course, terms and conditions. And here is the aspect. Sorry, I just went back. Here you can see the aspect of the main screen. We had some statistics for the users so they could see their, let's say, their performance in terms of energy consumption. There were some learning objects organized in different levels. So you would start in the first level. You need to watch one video, fill in some quizzes. So you have some activities linked to each level. And the idea was that the user progressed from simple, let's say, simple measures to increase energy efficiency to more complicated ones, covering several topics like lighting, air conditioning, energy saving at work, and appliances at home. So we covered several topics. About the videos were specifically developed in the project, and we had several types of videos, even a series of videos like I don't know, a series of Netflix, but about energy efficiency with 6 episodes. They were a bit long, 20, 30 minutes, this series of 6 videos, but we had several other videos covering other topics and teaching people to save energy. Energy savings was always the topic of these videos. And you can see on the right-hand side an example of one quiz with several questions, and in the end you would see your score in the quiz. Okay. We also had badges, which is typical in applications that use gamification techniques. So you'd have badges, also leaderboards, individual and even country leaderboards, because we had different countries involved. We also have notifications being constant contact with the user. They were also implemented to work with the system tray of your mobile phone. So even if you don't have the application running, you could receive the notifications via your mobile phone. And here's some more screens. We had a settings section, help to explain how the app worked, a screen to configure your account with avatar and several other stuff. Okay, this was in one end, so the part that was in contact with the user, but we also needed to have some sensors because we wanted to monitor 2 things: energy consumption, as I said, and these were the meters, but also the comfort conditions and indoor air quality conditions of the buildings that were part of the demonstration of the project. The problem was that there are a lot of sensors in the market, but they are a little bit expensive, or they have proprietary databases, so they only send the database to one single site, and you have to pay to access the site and extract the data of the sensors. So they're not expensive, but the service associated with the sensors is somewhat expensive, and even more if we consider that we wanted to install a lot of these sensors. So it was not in the middle, it was a little bit after the beginning of the project, we decided to develop our own sensor. So we have this here in this slide. It's a very simple sensor, very small, I would say 10 per 10 centimeters. And it has the capability of measuring temperature, humidity, CO2 concentration, luminosity, and those are the fourth more important indicators that we were measuring. So we developed several of them and we installed it in the demonstrators to collect this data. Okay, then in the back office, if you remember that first slide that I presented, we have the application and then we have the sensors and meters and the videos and also the database. And I said that in the server we had several applications. So to make all of this work as we wanted, we understood that we needed to develop several things. And the most important one, I will not go through all of these applications that are here, but one important thing is here, we understood that we needed to understand the users. So we had to do some user profiling, characterize the type of users that we had, and then a segmentation was to group them in different categories. So there were users that responded to, I don't know, financial incentives. Others were more concerned with the environment. Others were concerned with social aspects, for instance. Others simply with competition. They just responded to the competition that we created. So we made this first part. And then there was a set of tools that were very important for us to understand how the building was used in terms of energy. So we wanted to understand for the next day what would be the occupancy rate of each room, the energy that would be consumed, when it would be consumed, and the expected behavior of the users. To this end, we developed several things. You can see here we have a net load forecast algorithm, an occupancy forecast algorithm. We also have load disaggregation to understand which kind of the load profiles during the day of each type of load that we have in the building, like HVAC or lighting, or even plugs consumption, computers and stuff like that. And also the part of behavior predictor that we developed was intended to give us some notion of how the users in the day after would behave regarding lighting, regarding, I don't know, elevator utilization. So several aspects that we analyzed with this. So there was a lot of, let's say, ICT behind that application, that simple application that the users could see. Unfortunately, I don't have enough time to go through all these all these applications, but if you have doubts, you can ask afterwards. Regarding the demo sites, we had 3 demonstrators. One was in Porto, one office building, it was in Architect building. In Barcelona, we had 10 public buildings, including libraries and sports centers and schools. And in Germany, in Lippe, we had 25 houses. So we covered an office building, other types of public buildings, and the residential sector as well. Because it's very different when you want to change people's behavior at work, because they don't pay electricity, so you lose one incentive that you can use. The approach is different at home, because you are the one that pay the bill of electricity at the end of the month. So we wanted to test different types of buildings, different contexts, and even different climatic regions. That's why we use these 3 demonstrators. And now I went very fast through these solutions. Of course, we can discuss it later, but the most important part that I wanted to discuss are the results and the lessons that we learned. So the first thing is that, as you saw the duration of the project, when we were practically starting demonstration, we had the pandemic crisis of COVID-19, and it was a big problem for us. So this is the first remark that I wanted to do, because buildings in Porto and Barcelona were completely closed. So suddenly we had no users in the demonstrators. Energy savings could no longer be calculated as we planned, because we planned to calculate the energy savings using a technique that defines baselines for, imagine, one day. You define the baseline, and the baseline is the energy that would have been consumed in the building if you didn't implement any of the measures of the project. So this is reported in the literature, so it exists some methods to do this. And then we would compare the baseline with the real consumption measured by the meters, and the energy efficiency would be calculated like this. But suddenly we had no people in the building, so of course consumption decreased very considerably, and we were not able to do this calculation. And also the historical data sets that we used to establish the baselines were historical data sets from a period of a normal period without COVID-19. So with people in the building, we had a normal consumption, and the algorithms were not trained for this. Here you can see one slide just to understand the magnitude of the impact was really huge in the buildings. This is just an example. From Inarchitect, you can see this is from October 2019, September or October, and you can see the first week of April 2020, so after the pandemic and the closure of the building. You can see in blue the forecasted, so what we were expecting if there were no feedback measures, and the measured consumption is the orange line. When we pass for the post-pandemic period, you can see that the difference is huge. So the forecasted is almost in the same order of magnitude, but the real consumption dropped, I don't know, 60%, something like that, around more than 60%. So suddenly we were with a big issue, a big problem in our hands. So we had to make some changes to that initial plan to get some results. So we reconfigured the demonstration, and this reconfiguration was based in 2 or 3 main aspects. So the first one was we had to adapt that mobile application. Basically, we created a much simpler version of the mobile application that worked without meters and sensors. So this means that people the users were able to use the application at home, and they have access to all the levels, to all the videos, to learn and be more aware of their energy consumption, to the quizzes and everything, but we were not able to measure the energy efficiency as we wanted. So that measurement of the energy efficiency, and even more importantly of behavior change of the users, was made based on questionnaires and surveys. So it was the only option that we had by the time. Okay, and this is the last bullet. So we adjusted impact assessment to be based on self-reported attitudinal change, and we also did several focus groups to collect, let's to collect the opinions of the users with a more direct contact, to not rely only on surveys. With all the problems that we had, we even managed to have a significant number of users I was not expecting. So this was more or less our target when we had the initial plan. So we were targeting more or less 1,000 users, and we reached that number. You can see that afterwards we also released the application in Denmark and also in Switzerland, for instance, and Netherlands. That was not planned. Because the app was, I think, is still available in iOS and Android stores. So users could register from these countries, and we have these figures which are not bad for the context. The problem that we have, and this is the key point here, is the engagement of the users. We knew that this was an issue, but because other initiatives also had the same problem with different approaches, but the problem is always the same as the user engagement. So it's very difficult to attract the users for this type of applications, of initiatives, and make them last in time. But even so, we reached an important conclusion that I marked here, I think. Check it goes, the next slide, yeah. Because we, after checking these figures in very high detail, we reached the conclusion that all the users that passed level 4 and some level 3, so I would say level 3 to 4, they finished the game. So the majority of the users, they install the app, they register, they see the first level, but then they lose interest immediately. Those that passed the first, second, and reached the third and fourth levels, they went to till the end. So this is an important result or conclusion of what we did. But it was very difficult. You can see that the number, despite all the efforts that we did, the number of the users that reached the end of all levels, there were 14. There were a lot of videos, that's right. We know that, but only 26 in 979. So it's quite a low number. Now, important things that we can discuss later as well that we learned from these activities was that knowledge and ability are important, but willingness is essential. So this is the critical point. That the users must be willing to do this effort. One thing that eventually influences willingness, this is also one of the conclusions from our statistical analysis, that willingness is largely determined by comfort. So at least is influenced by comfort. You have here some statements from the participants. Some of them said, I don't want to change some things because of comfort reasons. For instance, some users were very aware of their excessive consumption in water heating, and but they were not prepared to reduce that type of comfort. On the opposite side, you have air conditioning. The majority of the users were, let's say, prepared to, or at least willing to reduce the temperature, for instance, in winter and the increase in summer. But there are some comfort aspects that are very important to convince users to do this. Some of other types of or other conclusion related with this is that to increase this let's say initial willingness of the user to do this, to learn and then to participate and to change behavior, is education, because we have a very strong example in the European Union, generally speaking, related with recycling. That worked very well. So there was a continuous process from, I don't know, since the 90s. There was a big investment in communication, in communication in general, in TVs, in radio, and everything. And even this was included in the school programs very soon. So people from the first, when they go to school for the first time, they start contacting with the importance of recycling. And you cannot find the energy efficiency or even water savings in this program. Now you can see a little bit, but it's just starting, at least in some of the countries. So this is a very important aspect to change willingness, and that can change or at least make people aware of the importance of saving energy in the future. In our case, most players were already quite knowledgeable about energy saving behaviors, but the game helped them to think more critically. So some of them said, I never thought that opening the fridge so many times could, they knew about energy efficiency, but they never thought that opening the fridge have a significant impact in the fridge consumption. So small things like that, they learned, they acknowledged that. Okay. So through slides ahead, just one more. Okay. One important thing was that the game was not initially designed for the utilization that it had. So this was one of the important conclusions. We should be design the application very carefully for the purpose that we want it to serve. Another final comment from my side is that, of course, that relying on self-assessment is not ideal, but we also learned that it shouldn't be underestimated. Some players can suddenly be more aware of certain small behaviors, and also encourages critical thinking. The final remark is that our data analysis suggests that behavior change can be achieved, but we should never compromise comfort of the user. So if you compromise comfort, or if you want to reduce comfort, it's very difficult to make some behavioral change lasting in time. It's very difficult. So comfort is a very important issue that should be taken into account as well. Okay, and this slide, I will pass it very fast. I don't have time. This one is just to tell you that we also analyze some important aspects for the implementation of a solution like this. And we did it in simplifying factors and complicating factors. So to understand if a solution like this can be implemented in a building, set of buildings, and there are some factors, characteristics of the buildings, characteristics of the users, and even business aspects and regulatory aspects that are important. And in some contexts, they simplify the implementation of a solution like this. In other contexts, they complicate, and it's more difficult to have something like this running. Okay, and finally, I just wanted to let you know who is the consortium, because this is not a project from INESC. INESC was coordinator, but we have a partner EPFL from Switzerland to Delft, some companies from Spain, UK, and Denmark. You can check all the information in the website of the project if you want, and you can also watch the final video that summarizes almost everything in the project. It's a long video, 20 minutes or so, but if you have time and patience, you can watch it. And for any doubt, you can contact me. I can't clarify in this meeting. Okay, so thank you very much for your attention.
Thank you very much, Philippe, for this. So in the meantime, we will go straight to the Q&A session with some questions to Philippe first, and we will see the result of the poll that we launched earlier in the beginning. So Philippe, maybe you can start reading the questions addressed to you in the chat in the meantime, and to see if we can see the results of the poll already.
Okay, so first question I have here is for Stefan. Is from Stefan. Did the energy used in the residence increase considerably in time when office energy went down? Yes, it increased, but not considerably. That's a good question. We were expecting that the consumption in the houses in Germany would increase, but the increase was, I don't know, 2 to 3%, not more than that. So we were also very, okay, what is happening? We're really expecting to double consumption, something like that. But the increase was very small. And then we tried to understand what happened. And in this specific context, they have heating and cooling and everything that's not electric. So we were in the houses, we were just monitoring electricity. We also monitored gas and water, but only in the other buildings, so in the office buildings and in public buildings. So in terms of energy, in terms of electricity, the consumption increase was really low. We were not expecting that, but that's what happened. And one of the reasons that part of the consumption or the energy consumption was fed by gas. Okay, so the second is also from Stefan. It says, is the app still active? Do you still monitor? Yes, the app is still active, but only in some countries because of property rights of some of the partners. We had to release only in the countries of the partners. So it is available. I think it's still available in Portugal, Spain, Germany, Switzerland, Denmark, and Netherlands. So those are the countries where you still have the application available. And we are still monitoring consumption and the points of the users. That's still running. So we have the obligation until the final meeting, which will be in the next month. But from the information I have, at least for 2 years, we will still monitor let's say, the entire infrastructure of the project. And how did you find your initial users? Well, the idea was to have some initial idea was to have some campaigns in the demonstrators, and the idea was only to engage users from the demonstrators. But after COVID-19, we made the application more general, so we were not relying more in sensors and meters that were installed in those buildings, so anyone could use the application. And we started advertising in social media, and a big part of the users that registered were not from the demonstrators, let's say. So initially we started in the demonstrators through institutional emails and some meetings that we organized to try to bring people to the project. But afterwards, we advertise in social media, LinkedIn, Facebook, and Twitter, and the website of the project.
Thank you very much, Philippe. I think now it's the time. Let's try to see the results of the poll here. Okay. So I guess users were really divided. Interesting. So between energy market development, supportive energy policies, and user engagement and awareness, which means we chose well the themes for our panel. So this is excellent. I would ask all the panelists, thanking them for their presentation, to please turn on their cameras and see if there are any last questions from the audience in this last presentation. So I don't see any final question, and apparently we have exhausted the time. So this means that we should have been really clear. We were very clear in what we presented. So thank you very much for all of you attending, and thank you very much especially to Laura, Yannick, and Philippe for these presentations. Very interesting. I think it gives us a very broad perspective of some of the challenges and some of the things that are going on related to this energy transition, and for making this the first list talk on this subject. So thank you very much, and hope to see you soon.
Thank you. Bye.
Thank you very much.
Thank you.
Bye-bye.
Thank you. Bye.